For this video, we're going to talk about the squeeze theorem. Basically, what the squeeze theorem does, it allows us to find the limits of very difficult functions to find a limit of. For example, we have the limit as x approaches 0 of x squared times sine to the 1 over x. We can't do this because we can't divide by 0 when we plug it in. We can't really factor anything out. We can't simplify any trig identities. We could try and graph it, but I want to show you how to do it by hand. So the best way to do this is to analyze the function a little bit. So we have two main components here. We have the sine function. Let me make that a different color. We have the sine function, and we have this x squared function. We know how to find the limit of an x squared function, alright? So let's keep that in mind. We also know a lot about the sine of x function. We know that sine bounces between -1 and 1. Alright, that just illustrates what we just said. So the sine function bounces between -1 and 1, so naturally sine of 1 over x will bounce between -1 and 1 as well. Back in the beginning of the problem, I said that this x squared was going to be very important. Okay, well that's what we're missing in this part right here. We have our sine of 1 over x, but we're missing that x squared. So what I'm going to do, I'm going to multiply everything by x squared. So all we did so far was that we realized that sine of 1 over x bounces between -1 and 1, and then we multiplied everything by x squared. So now, what's in the center here matches our original function. And we're sandwiched between two functions that are relatively easy to find the limit. So now we're going to see if we can find the limit of this function by taking the limit of everything. So now we have the limit of -x squared as x approaches 0, and the limit of x squared as x approaches 0, and our beginning limit is sandwiched between these two terms. So we're going to find the limit of both these guys. So the limit as x approaches 0 of -x squared, that is going to be 0. The limit of x squared as x approaches 0 is 0. So what happened now is our original limit is sandwiched between 0 and 0. So if our limit is greater than 0, or greater than or equal to 0, and it has to be less than or equal to 0, there's only one true option. It has to be 0. So here is a graphical description of what we just did. Looking at this graph, the middle function here, that is our x squared sine of 1 over x. And these little red functions, this is our x squared, this is our -x squared. And we saw that as if we can sandwich our function here between these two graphs, we can eventually find the limit as x approaches 0. And there we have it. That is the squeeze theorem to a T. Now I'll give you guys one practice problem because it is kind of difficult to imagine. But when we get to class, we'll do some more examples and hopefully it'll become concrete. Alright, looking at this problem, I said using the squeeze theorem, show that the limit as x approaches infinity of sine of x over x equals 0. Try this out. Ask questions if you need it. Otherwise, have a good night.